Hello. In this video, I'm going to be solving 3 exercises from section 2.2 of Jiří Lebel's Notes on Diffy Qs. The link to his notes will be in the description. So the 3 exercises are all constant coefficient second order linear ODEs. And the 3 that we're going to solve today are y double prime plus 9y minus 10y equals 0, which is exercise 2.2.7. We're also doing 2.2.8, which gives us y double prime minus 8y prime plus 16y equals 0, subject to these initial conditions. And finally, we have exercise 2.2.11, which asks for the general solution of y double prime plus 6y prime plus 13y equals 0. Okay, so let's get started with the first differential equation. So this is a second order linear homogeneous constant coefficient ODE. And the way to solve these is by first solving their characteristic equation. And the characteristic equation for this ODE is going to be, we just have to match up the powers of r. So r squared corresponds to y double prime with the derivatives of y, making sure to add the coefficients along the way. So for this equation here, the characteristic equation is r squared plus 9r, because we have a 9 here, minus 10, corresponding to the y, and this is equal to 0. And so our job is to solve this equation now. Well, this isn't so bad. You might notice that if we take, so we can form negative 10 by doing positive 10 times negative 1. And it also happens that 10 plus negative 1 gives us 9. And so this equation factors as r plus 10, r minus 1 equals 0. And we can quickly check just to give her feel at ease. R squared minus r plus 10r, so minus r plus 10r gives us 9r, good. And then 10 times negative 1 gives us negative 10. Very nice. And so from this equation, we can see that either r equals negative 10 or r equals 1. And so the general solution, therefore, because this differential equation is homogeneous, we can express this solution family as y equals some constant c1 times e to the first root times x, so e to negative 10x, plus c2, e to the, well, 1 times x is just x. So this is e to the x. How about this equation? Well, again, we're in a similar situation as before. So we have a second order linear homogeneous constant coefficient ODE. And so our first task is going to be to solve the characteristic equation, which in our case is r squared minus 8r plus 16 equals 0. And by factoring or otherwise, one thing we can see is that this left side is equal to, and I'll put this in blue, this whole left side is equal to r minus 4 squared. And again, we can check this by hand if we like. So that means that our equation is r minus 4 squared equals 0. But then what this tells me is that 4 is a repeated root of the characteristic equation. And we can check that this is repeated by also checking the, the discriminants. So we can also check that this is repeated with the discriminants. And as a reminder, the discriminants of a quadratic. So let's say we have a quadratic ax squared plus bx plus c. Its discriminant is just b squared minus 4ac. And so in our case, the discriminants, well, b is going to be -8 and our c is going to be 16. So we need to compute -8 squared minus 4. Our a is 1. And again, our c is 16. So we're computing this quantity here, which is 64 minus 64, and this is 0. And so when the discriminant is 0, we have a repeated root. Now, when we have a repeated root, the way we write the general solution is as follows. So take this, what I'm writing, as a template, and I'll move it over here for some organization. So our general solution is going to be y equals some constant c1 times e to the whatever our root was. So in this case, it was 4 times x. So it's just like the previous case. But our other function with the c2 is going to be x times e to the same root. So in this case, x times e to the 4x. And if you like, you can check by hand that this does indeed solve our differential equation. Okay, now that we have this settled, our next task is going to be to figure out what C1 and C2 have to be. Because remember that in this case, we have initial conditions. So let us go here and plug these in. So plugging in initial conditions, what do we get? We are going to get, well, our first condition tells us that 2 is equal to y0. So 2 equals c1. If we plug in 0 for x, we get e to the 4 times 0, which is e to the 0, which is 1. So that just becomes 1. This is, oops, just trying to clean this up, C1. And our second term, well, again, we're plugging in 0. And so we just need to plug it into the x, and we already see that that's 0. So we're just left with 2 is equal to C1. To plug in the next condition, though, notice that we have this y prime. So first we have to find what the derivative of our general solution is. And I'm going to write this in blue. Y prime is going to be, well, just doing the chain rule, 4c1 e to the 4x plus c2, and here we need to use the product rule, e to the 4x plus 4x e to the 4x. And this whole thing is going to simplify to, just doing some mental math, 4c1 plus c2 e to the 4x plus 4c2 x e to the 4x. Now let me just double check this. Okay, so we got this derivative, nice. And then when we differentiate this with the product rule, we get this. And so distributing the c2, we get a c2 here, which we've accounted for here. And we have a c2 for the 4, x e to the 4x, and we've accounted that right here. Okay, so now for our next initial condition, we're given that y prime of 0 is 0. So if we plug in 0 into this equation here, the left side will be 0, but the right side is going to be, well, if we plug in 0 for e to the 4x, again, it's just 1. So we get 4c1 plus c2. And once again, plugging in 0, because that's what we're plugging in. This vanishes, and so this is our second equation at that point. And this isn't so bad to solve. We already know what C2 is. And to find out what C1 is, we just need to plug it into the second equation. So 0 equals 4C1 plus 2, which tells me that C1 is, oh, oops, I plugged it into the wrong variable. So I plugged it into C2 instead of C1. What I meant to say is that 0 is equal to 4 times 2 plus C2. And so this gives me that C2 is negative 8. And thus, the solution corresponding to our initial conditions is given by y is equal to, now we just plug in these constants back into our general formula. Y is equal to 2e to the 4x minus 8x e to the 4x. Nice. And this leaves us with the last equation. Nothing different. First thing we're doing is the characteristic equation, which in our case is r squared plus xr plus 13 is equal to 0. And so here, I'm going to use the method of completing the square. So if I take this 6 and I divide it by 2, then square it. Or squared. So divided by 2, it's 3. So I'm going to add 3 squared. And I'm going to subtract 3 squared. And then plus 13 is equal to 0. And so just doing the completing the square, this becomes r plus 3 all squared. And so here we have 13 minus, well, 3 squared is equal to 9. So we have 13 minus 9, which is 4, which is equal to 0. And this in turn is r plus 3 squared equals negative 4. Alternatively, we could also use the quadratic formula. I'll illustrate the quadratic formula roots in just a bit. I'm just going to finish solving this equation. So already, just because we have this square, we're squaring this, but there's a negative on the right, we can expect complex number solutions. So when we take the square roots, we have r plus 3 equals plus or minus the square root of negative 4. And this is imaginary, so we need to write this as plus or minus I root 4, which is what happens because we take the square root of negative 1. And this in turn is plus or minus 2i. And so we have r is equal to 3 plus or minus 2i as our roots. Once again, as an alternative, let me illustrate the same procedure with the quadratic formula. And this will serve as a gut check to make sure that these roots that I already made a mistake. That's supposed to be a minus. What I was going to say is this will serve as a gut check to make sure that the roots that we got here are actually the roots of our equation. So the quadratic formula tells us that r is going to be, just going back to this first equation, negative b, and our b is 6, so negative 6 plus or minus roots 6 squared minus 4, our a is 1, so times 1, and then times 13, all over 2 times a, which is 1. So we just have 2 here. And, I'm writing in black. Oops. Let me change the color to be consistent. There we go. Okay. So we have this. And so just continuing, negative 6 plus or minus. What is 6 squared minus this? So 6 squared is 36. 13 times 4 is 30, 26, 52. So we have 36 minus 52 all over 2. This is negative 6 plus or minus 36 minus 52 is, give me one sec, 4, 14, 16. So this is minus 16. Oops. No, we're good. Okay. All over 2. And once again, because we're taking the square root of something negative, this is going to become I times the root of the positive thing. So we go from negative 16 to positive 16, all over 2. Now, the square root of negative 16 is just 4, so we get 4i all over 2. And this, in turn, is negative 3 plus or minus 2i, which is exactly what we got using the completing the square method. Okay, very nice. Now, how do we write the general solution to our differential equation when we have imaginary roots like this? What we're going to do is, so let me write this. What we're going to do is we're going to take, so same thing, we still have one constant for the first term, and we're going to take e, and we're raising it to what's called the real parts of our complex roots. So this is just this number right here, the one that doesn't have an I next to it. Negative 3x, and then we're doing cosine, and the cosine is going to be of whatever number is occurring in front of the I. So ignoring the plus or minus, just look at this number. It's going to be cosine of 2x. And then we're going to do a similar thing, C2, and we're raising e again to the same part, so the same real part, negative 3x. But now we're doing sine of the same number, 2, occurring in front of the I. This is 2x here. And this right here gives us our desired formula. This gives us our final general solution. All right, that is it for this video. If there are any questions, please feel free to leave a comment. Otherwise, I'll see you all in the next video.